Velkommen til Maskinmestrenes Podcast. En podcast fra Maskinmestrenes Forening. Din vært er Anders Kampmann.
Fremtidens grønnere brændstoffer til skibsfarten er ikke alene en tilbagevendende emne her på Maskinmestrenes Podcast, men også et særdeles vigtigt arbejdsområde for en række virksomheder i den maritime industri. Vi har for nylig talt med fonden Maskinmestrenes Center for Zero Carbon Shipping og energiteknologivirksomheden Stigsdal om udvikling på området, og den snak bygger vi på mange måder videre på i dagens udsendelse. Omdrejningsprojektet i dag er projektet Metafuel, der udvikler et matrixbaseret metode, som kan støtte sikkerhedsmæssige beslutninger fra maritime interessenter, relateret til de nye brændstoftyper metanol, ammoniak og brint. Projektet finansieres af Den Danske Maritime Fond og DBI, Dansk Brand og sikringsteknisk Institut, hvor vi er på besøg i dag. In order to dive deeper into said project and not least introduce our host and guest, I have now obviously switched to English. Allow me to introduce Leonard Sang Tuei.
Yeah.
Hope I got that sort of correct.
Yeah.
Project leader on the Metafuel project here at DBI, and his colleague Anders Viborg Kristensen, global business developer and also master mariner.
Yeah.
As of taping in mid-November, the project is nearing completion due in December, so today very much seems appropriate for a status update on the efforts to support a successful, safe and economically efficient green transition. So welcome both, Anders and Leonard.
Yeah,
welcome. Thanks for hosting us here at DBI.
Yeah.
As I start off by saying the Metafuel project is well underway. A report is actually finished, as I gathered, Leonard.
Yeah, pending a few reviews and comments. It's kind of done. Yeah.
So that will be the focal point for us today.
Yeah.
As standard goes here on the podcast, we start off by introducing our guests. Leonard's the main author, I guess I can say, on the report. I thought we should start off with you. Originally from Kenya, moved to Sweden in 2016 and built on a degree, ending up as a mechanical engineer. Then coming to Copenhagen last year, you've been here at DBI for since March.
Yeah.
So maybe you can elaborate on your background and obviously your role here at DBI.
Yeah. I'm a mechanical engineer by profession. I have a degree and a master's as well. Also a business degree. I have a background within the energy transport and within energy and transport itself. I've worked in electrification of transport in Scania in Sweden, and also around internal combustion engines for both transport and marine application. Yeah.
And Anders, you have the more maritime background. I think a lot of our listeners can relate to. Originally a master mariner, skibsfører from the Fanø Navigation School, 1999, 15 years with Maersk, 10 years at the Danish Maritime Authority, and then a project leader here at DBI as well for almost 4 years by now.
Yes, that's correct.
So maybe a word or two on your career so far, a lot of years at sea.
Yes, I certainly have a maritime background, you can say. A lot of time at sea as a master mariner and joined the DMA. Later on, I had 10 good years at the DMA on both as a technical advisor, but also as a special advisor to the DMA during IMO questions, EU legislation, IMO legislation, head of Danish delegation and subcommittees at IMO on life-saving equipment, dangerous goods, etc. And I joined the DBI back in December 2021, and I'm approaching 4 years. Started as a project manager, and now I'm a global business developer.
You must have kept a close eye on the developments within the IMO and the regulations that didn't come to reality just lately.
Yes, absolutely. We keep a very close eye, and we're also assisting the DMA in several cases in IMO-related questions. We're advisor to the DMA. And yes, the last IMO meeting on the green transition was a big surprise in a way, but I think it's only postponing, it's not cancelling. So we are still optimistic about the future on the green transition.
Well, you have to be, at least, I guess.
Yes, of course. But it will come. I mean, I don't think we can live without it, and we will find a way through it for sure.
So going on into the Metafuel project here, you were in the developing phase and scoping the project. So maybe you can sort of lay out the background and also, I guess, why DBI is involved with this. I mean, your area of expertise is very much around fire safety and concerns regarding the handling of the fuels I mentioned. So how did this project come underway?
Yes, thanks for the question. When we did the application, we wanted to look more into the details. We often hear talks on where to get the fuel, how to get the fuel, will there be enough fuel? And we wanted to go more into details, looking into how can you make sure that when we get the fuel at sea, we can have proper equipment to handle the fuel, we can have proper equipment to detect any leak or fire, and also extinguishing the fire with proper ways. And ensuring that the crew has the right equipment, the right firefighting equipment, right fire suits, extinguishing systems, etc. Because that's going into the details. You can say we came down from the helicopter view and went more into the details on how to really handle the fuels at sea. It also includes bunkering procedures. From when you get the fuel on board, in the ports until you use it on board, and make sure that everything can be done in a safe manner, and that you have the right measures to handle any incidents and accidents.
And some of these new fuel types come with some new sort of risks, I guess, not least ammonia, which it's by nature toxic, and you can detect it quite easily in your nose before it gets dangerous, I suppose. But there's a lot of there must be some concerns to address in that regard.
Absolutely, and also comparing what we used to do in the old days, as I say, we bunker heavy fuel oil or diesel oil. Mariners who have been at sea know how to do that. We've done it for many, many years. So that's not really new. Now we're introducing new fuels. We have to do new procedures. We have to make sure that it can be done in a safe way. So the transition from black fuels to green fuels is not only black to green, it's also a lot of new procedures you have to realize, and you have to have the right approach to make sure that it can be carried out. So that's the idea of looking into it.
So let's look at this a bit more at the project. Let us. You were, I guess, sort of thrown into it.
Yeah, exactly.
7 months ago.
Yeah.
I had to pick up the project started in May 2024, and as I said, is well almost wrapped up by now. So you may describe your process and coming into the project.
Yeah, of course. Thank you for the question. Of course, the project initially started by mapping out the fuel properties for both ammonia, methanol, and hydrogen. And after that, look at the safety hazards when the fuels are used on board a ship. After that, we kind of zoned out the fuel handling areas of a ship, right from bunkering up to the use of the fuel in the engine room. So of course we have storage in there, and then preparing the fuel in the fuel preparation room for use in the engine room. And then after that, we kind of thought, what other supporting aspects should we look at? Of course, we have to look at the regulation. What do the regulations say? Kind of a regulation overview, look at IMO documents, classification documents, from Bureau Veritas, DNV, ABS and all that. We also mapped out the kind of risk assessment tools that might need to be used while designing your ship. Of course, we borrowed a lot from the risk-based approach of looking at this while implementing the project. And then we also analyze the human factors. Of course, while these fuels are used in the ship, there is a huge role played by human beings. So you need to design, the handling, whatever you need to, the components in your vessel or ship to be able to be used by humans and all that. And then after that, we went to, after analyzing the hazards and looking at other supporting aspects that I just described, we went and see which safety functions, in this case, which risk reduction measures do we have to put in place to mitigate the hazards which are inherent in these fuels. And then from that, we kind of carried out a gap analysis, which is based on the regulation and guidelines, IMO. Of course, for ammonia, we looked at the interim guideline for ammonia, which was released early this year, the IGF code, and then the classification documents. All the classification societies have guidelines for ammonia. For methanol, we also looked at the interim guideline, the IGF code, and the documents from the classification societies. For hydrogen, it's still developing. And during our analysis, we didn't have the interim guideline. So we mainly based it on the IGF code, which is LNG based, and also the classification society documents, which goes into the details for hydrogen. And after that, we developed a kind of gap analysis matrix, which is kind of looking at the fuel handling zones, look at the readiness or maturity based on the technology readiness level framework. And then we kind of developed a heat map that could show what level of readiness for each of the fuel handling zones are we in each of the fuels. And then from the gaps that we identified, we at DPI figured out that we need to show the industry how we can close these gaps. So we picked 2 examples. One of them is methanol fire suppression. We did some tests internally using our Mobat facility here at DPI. So we kind of tested different nozzles for suppressing fire within an enclosed space in an engine room, and then look at the placement of nozzles within the space. Did that analysis. We have some results. Then we also picked a simulation of ammonia even in case of a leakage during bunkering, and then see for different scenarios. We analyzed like 20 scenarios. If there's a leakage at the port, how does it spread and how wide does it spread depending on what sort of ammonia you're handling. If it's whether it's semi-refrigerated ammonia or fully refrigerated ammonia, how does it spread? Of course, at different times of the year, whether it's summer, winter, conditions, wind, all that. Got some results. These are kind of guiding results for the industry that could be used on risk-based project approvals at the moment. And then, of course, most importantly, we decided to develop, while working on the project, we realized that the industry could need a decision tool, a tool that can be used by maritime stakeholders, whichever stakeholder it is. Then the stakeholder can log into the tool, for example, state who they are, what kind of engine they are like, what kind of fuel they want to design their engine their ship based on, what kind of ship they are looking into, and then specify as well the fuel handling area they want to look at. Fuel handling zone in this case, is it the bunkering zone? Is it the transfer, the storage itself, transfer the fuel preparation room from the storage tanks, and then use in the engine room. And then we gave some recommendations and kind of roadmaps for the industry to follow. So we sort of developed a methodology that could be used by maritime stakeholders to make decisions in each of the 3 fuels.
These are fuels with a lot of potential to reduce greenhouse gas emissions across the shipping sector, and I guess also other modes of transportation and land-based activity as well. But do they have a sort of a common denominator in terms of safety and handling? And these gaps you mentioned is something some properties that they share in terms of how to handle them?
Yeah, of course. Each of the 3 fuels has different inherent properties. For example, if you look at methanol, it has it is very highly flammable. So it has low flash point of around 11 degrees. It's highly toxic while ingested or inhaled. And also when it burns, its flame is invisible. So it's really kind of difficult to detect. When you look at ammonia, it's highly toxic, as you know it. It's also very corrosive. Let me go back to methanol as well. It's also corrosive, so you have to kind of put your mind on which materials you'll use for storage, for example, and which kind of coatings you'll use for your tanks. Back to ammonia. Ammonia is mildly flammable, so while designing your vessel or ship, you don't really pay much attention to flammability as methanol or hydrogen. You pay attention to toxicity as a guiding factor. When it comes to hydrogen, it's highly flammable. It could cause catastrophic explosions. Its properties such that it needs really small amount of energy to ignite. Its minimum ignition energy is quite low, in values of 0.0 millijoules. It also has, depending on how hydrogen is stored, if it's stored in a liquid form and then it leaks, it expands up to 850 times. So high expansion ratio, and that could really, be catastrophic because it spreads. So you have to pay attention, for example, to how you place your detectors. Should be placed on high points, things like that. And also, of course, if it's stored in refrigerated form, it's very low temperatures, -253 degrees. So it has cold cryogenic hazards as well. Yeah, such kind of things. This is just surface level. We went so deep in the project itself, and it could be found in the report. Yeah.
Du kan altid finde flere udgaver af Maskinmestrenes podcast på mmf.dk/podcast eller på Spotify.
So a lot of different safety hazards within. You've done some testing here at DBI at your own facilities. Anders, maybe you can elaborate a bit on how those tests are carried out.
Yeah, actually, I think I would like Leonard to elaborate a bit on that. He did the tests.
Yeah. I mean, for the testing that we did, it was focused on methanol separation. The idea was we need to actually simulate the actual good condition in a ship's engine room, but we were limited in the facility to use. Right. So we used our DPI internal facility called Mobat. It's a container with a hood, and you can place your nozzles above it. You can place your flame or a methanol pool below it, start your flame, and then try extinguish it. Of course, we also used infrared cameras to show that you are able to see the flame. If you use the infrared cameras, you cannot see with your naked eye, at least during the day. We also did some comparisons between flammability of methanol and gasoline, and then to kind of show that they have different combustion properties in that sense. Then we tried different nozzles to see the effect of flow rate and placement of nozzles around the fire. For example, we started with a pool fire at the center of the Mobat facility, and then we tried 2 different nozzles, and then we moved the pool fire to the side of the Mobat facility, and then used the 2 different nozzles, and then moved to the corner as well of the Mobat facility, and then used the 2 different nozzles. And what we observed from this is that the extinguishability of a fire using water mist highly depends on one placement of the nozzle and the K factor, which is the kind of the flow rate and the pressure with which the nozzle emits or ejects the water mist itself. That's basically what we did. Of course, this test needs more tests, and at the moment we are working on another project called Mephisto. It's methanol fire safety tools. So we are deep diving more into how best can we detect and extinguish methanol fires within the engine room. And in this new project, we are actually going to use an actual engine room of a ship.
So a lot of very specific demands for the mariners out there, and in terms of suppressing these fires and handling potentially dangerous situations. Anders, how do you think the maritime sector is equipped or ready for the terms of the readiness state? How do you think the sector stands at this point?
Well, you can say following the IMO meeting not long ago, where the big decisions were postponed temporarily, I would say, there are vessels out there now operating, and that means that there are crew out there operating in under these terms, and they have to, of course, be able to get the ship from A to B in a safe manner, so that there are getting more and more crew members that have experience handling these different types of fuels, and that's also one of our focus areas, to educate to the crew in the terms of making available courses and for crews on how to handle the green fuels, starting at a lower level, because that's where we are right now. That's where the man on the deck has to know how to handle, what to do in case of a leak or in case of a fire or any incident that could occur. So that's also some of the things that we supply here at DBI. And that's one thing. I also know that, of course, shipping companies want to continue to do what they have always done. They want to come into a port with their ship. They want to do cargo operation, loading, discharging. They want to change crew. They want to get provisions. Maybe they want to do some minor repairs, etc. Bunkering. And they want to do it all at once. Yeah. That also means that when we go more into the green transition, and when we see more green fuels in ports, we have to be able to do it all at once. And in order to do that, we have to make sure that we have looked through all the details and really, making sure that we can still bunker while we do cargo operation, taking into consideration the new risks that the new fuels present to the port area and the vessel. I certainly believe that that's possible, provided that we do a proper work, as we've shown here with Metafuel, and also what we're looking forward to see with the Mephisto that Leonard will also take care of. So to make sure that we can continue business as usual, but using new fuels, and it seems so easy. It will not be that easy, but it will be doable when we get into the details.
You know that your former employer Maersk is very much a front runner on using methanol on the container vessels. A lot of new builds coming at large scale as well, closing on I think something like 18,000 TEU now. With the magazine Maskinmestrenes, we've visited Maersk a couple of years ago. Pretty much the first one in Maersk's fleet, somewhat smaller, but still a good example in this. I remember talking to the chief engineer, who was a bit not hesitant at first, but looking into methanol, said, "What's this? Where are we going with this?" And then they took the IGF course in Finland, I think. Yeah. And started using it, and he was like, "It's not so bad.
No,
it's not. We got used to some new procedures and some new stuff to think about, especially in terms of bunkering. But once you get going, pretty much as same as everyday life on heavy fuel oil. So maybe you shouldn't worry too much, I suppose."
No, you can say, and of course, Maersk being one of the biggest shipping companies in the world, and they have the capacity to be a front runner and also the will to do it, and that's of course important that they invest and they decide that this is what they want to do. So for them, it's slightly easier, you could say, because they have decided this is what they want. What for other smaller companies, I could maybe be a bit more not concerned, but at least worried to say that they need to start from scratch. And from scratch, that might be a bit far away from them. So that's where we also want to. I mean, Mephisto will be Metafuel is certainly a helping hand to them, because then we pave a lot of the road ahead of them for them to start at a more enlightened spot, you could say.
And that's also obviously which Maersk is very much aware of some concerns regarding the availability of a fuel like methanol, which has to be produced ideally from green sources, so as to be sort of maybe not too neutral, but at least less intensive. But how do you see methanol playing a factor going forward in the maritime industry, and with a project like Metafuel, is going to be available for more of these stakeholders in the future?
Yeah, at least from the perspective of Metafuel and the gap analysis that we did, our feeling is that methanol is a front runner. Of course, psychologically, I think the industry is more prepared for methanol because it's close to gasoline. Yeah. So in that sense, even when we looked at the gap analysis, which is based on technology readiness level, you could see that from bunkering, the bunker station to use of fuel in the engine room, there is quite a good understanding of how methanol works. And we also should thank Maersk, because we had a visit to the Lower Maersk vessel to look at their fuel handling and fuel handling areas, ask them questions, ask the crew, for example, the human factors, how they'll handle fires if there is. And we learned a lot from them so that we used the information to implement this project. Methanol as a space, for example, there are challenges with it, availability, price, and all that. But I think with time, the maturity will get to where the industry needs to get to. Yeah.
But these sort of cross-industry collaboration issues or efforts must be crucial in order to forward a fuel like methanol and the other greener options. And that must be something you're looking very much into here at DBI as well.
Yeah, of course. As much as we are focused on safety, of course, it's really important as well to look at the future and the maturity levels. Of course, methanol is kind of the leading from our analysis. Ammonia follows closely, and then hydrogen is still a bit behind because there are issues with handling. Yeah, it's based on its properties. But generally, I think we are positive about the future of these fuels. Of course, the Metafuel as designed is just meant to show the industry how to, the future. But I think in future we'll have to expand more, dive into other new fuels that come into the picture, and DPI is at the forefront of that, to look at the safety aspects of all these new fuels. Yeah.
So now we talked a bit about Maersk, but going forward, how could a smaller shipping liner company with maybe a fleet of 5, 10, 15 ships who hasn't really taken on the green transition yet, how can they utilize a report or a piece of work like the Metafuel project here?
Of course, the report itself, we designed the report so that if you are a marine stakeholder, let's say a small shipping company, you could look at the fuel properties from there, and then we kind of zoned the fuel handling areas of a ship based on what's in the regulatory documents, so that it's easy for a stakeholder, let's say a shipyard or a ship owner, to kind of read through, like, we are starting from bunkering. What are the fuel hazards? What are the hazards relevant to methanol, ammonia, and hydrogen at the bunkering station? What are the fuel hazards? And what should I think about while thinking about the storage? We also propose different storage forms of these fuels and the kind of tanks they'll use and all that. What should I think about in the fuel preparation room? How will I vaporize my cryogenic hydrogen or methanol, or ammonia, and then how do I use them in the engine itself? So we have a decision tool that we are in the development stage. We are finalizing it, but we propose it in the report and how it works. So any marine stakeholder who actually wants to use the decision tool to simplify their safety, their decision on which kind of fuel, they could contact us at DPI, and we could help them, guide them through it and all that. So the report itself is just an introduction, but it's a good guideline on what to think about and the safety considerations that should be put in place by whoever it is within the industry who wants to consider any of the three fuels. Yeah.
So some of these maritime stakeholders, maybe in the sort of SME scope, if they reach out to you, Anders, what kind of guidance can they look forward to?
The guidance will, of course, start with the Metafuel project that we can supply them with, and also this decision tool that Leonard mentioned. In this decision tool, as I remember, there's also references to regulation, so instead of reading through all of the different regulations, we will pinpoint you in on what regulation is relevant for you. So that can certainly be an assistance to the companies. We can also help them on the documentation part. Of course, they would often use the classification societies, but we have the insight of the regulation and the requirements, so we can direct them in the right way. And we certainly also see this Metafuel as the first stepping point for the next projects, looking into, as Leonard said, other fuels. We want to do something similar for ammonia, for methanol, and we have the small sidekick in the sense of battery. We would probably be looking into dual fuels, where we would use methanol, ammonia, hydrogen, and then have a battery next to it that can take off the peak power.
LNG, perhaps?
Maybe LNG, yeah. These are the first stepping stones from our point of view, and it's a really interesting future we're looking into from a green perspective. The new green fuels, it's the biggest transition in the merchant navy in the last 50 years, I would say. So it's a really interesting time.
Can I say something now about the decision tool? So in this decision tool, you kind of have your inputs as a user of the decision tool. Let's say you are a marine stakeholder. Let's say you are a port authority for example, a shipping designer or a marine insurer. So you check into the tool, choose who you are as a stakeholder. You choose the kind of fuel you are interested in, methanol, ammonia, hydrogen, whatever. And then you also choose the type of ship. Is it a new build? Is it a retrofit? In future, we tend to think that we'll develop it into tool where you can choose whether it's a container ship, a bulk carrier, or a tanker. And then you also choose which fuel handling zone are you interested in, like the bunker station, the storage tank, engine room, fuel preparation room. And then once you give all that information, the decision tool computes it internally and does some analysis or its magic. And then the outputs will be like the safety considerations, like what kind of hazard should I pay attention to in the bunkering station or in the engine room, whatever. You'd have chosen that before. And then you get the risk reduction measures. What should you then put in place to mitigate for the hazards that within the bunkering station or the engine room? And then you get a reference document. Is it the RGF code? Is it the interim guideline? And also whether it's any of the class society documents. And then, of course, you get the reference as well to the chapters, the specific chapters in the regulation and documents. And after that, lastly, and most importantly, you get stakeholder-specific recommendations, like recommendations that apply to you on what you need to do. So basically, we are trying to have the industry get ahead instead of reading the documents and thinking about what they need to do. We can give them these recommendations, which are specific to them.
So some very concrete benefits to gain from this tool, I guess. So rounding off here, what's your should I say ideal or maybe even dream scenario for the report? I mean, how do you see it getting a life of its own and really sort of being used by the industry?
Of course, we'd like the report to be a live document that's used in the industry so that it doesn't become any other report because there are so many reports today. But I think with how we've structured it with it's a kind of an actionable tool on what you really need to think about. Sometimes we don't give the actual numbers, but we give the industry what needs to be considered while in terms of safety and all that. We hope that this is a starting point, and then, of course, we continue. We mapped out as kind of a roadmap where in the near term, we need to continue using these risk-based methods that we propose, and then do more testing, more simulation, like the kind of tests that we did, and what that we are doing, simulations that we did and that we continue doing, collect that information, and in the midterm, then use this evidence to speed up approval of projects. And then in the long term, after collecting enough information, which we hope these kind of projects help gather evidence, we get prescriptive rules quite faster based on this kind of work.
Yeah, if I may add, of course, we will certainly take the knowledge that we're gaining and assist and also forward to the Danish Maritime Authority for them to consider and to hopefully send to IMO to improve and to get you could say speed up the process of getting more prescriptive regulation, or at least regulation that you can use rather than doing risk assessments, because this work that we've done for now is also to be used in the transition period from no regulation to prescriptive regulation. And maybe if we talk in 10, 15 years from now, the three of us, we will have IMO regulations already in place, maybe 20 years from now. But eventually we will have the regulation. Of course, we would like to see that our great work is part of that as well.
I guess we can only hope the best for the report and the green transition in the maritime industry in general. I suppose that must be in all of our common interest to see that progress going forward. So Leonard, Anders, thank you very much for a great talk on maritime fuels in the future here at DBI Today. Masser mere snak om blandt andet grønne brændstoffer og rigtig meget andet på MMF.dk, på Spotify og på iTunes.
Du har lyttet til Maskinmestrenes Podcast, en podcast fra Maskinmestrenes Forening. Tak fordi du lyttede med.